Good morning, everybody. I hope everybody is doing well. Any questions for me? I hope you keep up with the announcements I make on Canvas. As I said, when you try to log on to Zoom through Canvas, the records, I made a folder in Zoom section. It's called Zoom Meetings. It's called Zoom Meetings Links. You can find the links in that folder, and if you copy and paste onto your browser, it will get you the recording. No problem. Yeah, if you're a Mac user, Safari is given hard time, so please use Mozilla Firefox or Google Chrome. Did everybody have difficulties with logging into the meeting? I'm assuming not. So I think we can go ahead and start. We're going to cover 11.2 today. You're muted right now, but you can unmute yourself whenever you want, and you can turn on your video as well if you want to show me a scratch work or any equations, something like that. I think we're good to start. As I said on Monday, I regularly check the chat. So if you have any questions, you can just type it on the chat, and I'll try to answer it right away. By the way, whatever I'm writing right now, I mean, this paper, I'll post it on Canvas. I'll scan it after the class, and I'll post it on Canvas, so you'll be able to see it, and you're also able to see the recording. So let's start with recalling sequence. What was a sequence? We covered it in 11.1, but I know it's been a long while. A sequence is pretty much a function. The only difference is the values we plug in must be positive whole numbers. It doesn't have to be finite, it can be infinite. And this is how we show it. And an is called the nth term or general term. So remember, we did some examples regarding sequence, finding a certain number of terms of a sequence, and then finding the general term of a sequence, and then examples regarding determining if a sequence is convergent or divergent. And to do that, we're just taking the limit of the general term of the sequence as n goes to infinity, and using the limit laws we know from calculus 1, we're trying to figure out the limit. If it's a finite number, it's convergent. If it doesn't exist, or infinity or negative infinity, it's divergent. So that's what we covered in 11.1. Now, let's try to define series. So if we add please let me know if you're having difficulties with this. If we add the terms of an infinite sequence an from 1 to infinity, then we get a1 plus a2, a1 plus a2 plus a3 all the way to the n term, and then it keeps going, which is called infinite series, and is denoted by the sigma sum. Or sometimes we don't put the upper and lower index. We just call it sigma an. Oops. Can everybody see the screen fine? Okay, and then let's write out the formal definition. Let's Sn denote the nth partial sum of a given series. What does that mean? It means the sum of first n terms. So if we write out an infinite series, a1, a2, a3, all the way to the infinity, then Sn means I'm going to use a different index. Sn means the sum of first n terms from 1 to n, ai, which is going to be a1 plus a2 plus, and it will stop at an. So that's the definition of partial sum. If the sequence Sn, the sequence of partial sums, is convergent, which means the limit of Sn's is finite number S, exists as a real number, let's say, then the series an is called convergent. And we write the sum of the entire series is equal to S. And then if the sequence Sn is divergent, then the series is called divergent. So basically what this tells us is if you want to determine if a series is convergent or divergent, an infinite series, what you can do is you can check its partial sums. If the sequence of the partial sums is convergent, so is the series. If the sequence of the partial sums is divergent, then the series is divergent too. Any questions so far? So if you feel like you have no idea what's going on, that's fine, because that's how I felt when the first time when I saw the series. So no worries, you'll try to understand pretty soon as we move to computational examples. So one of the most common examples of series is geometric series. I think somebody has a question. Yeah, if the sum is a finite real number, it can be any real number, then it's convergent. If it's infinity, negative infinity, or if the limit doesn't exist, then it's divergent. So it's pretty much the same as the section 11.1, what we did for the sequences. Any other questions so far? Okay, let's keep going. So let's define the geometric series, which is one of the most commonly used series. So each term is obtained from the preceding one by multiplying it by the common ratio R, and I'll explain what it means. So if your first term, let's assume your first term is A, we don't know what it is. To find the second term, you need to multiply A by R. So now you have A times R. To find the next term, you need to multiply A times R by R. Then what would you obtain? A times R is going to be A R squared. And the fourth term, if you multiply this guy by R, you would get A times R cubed. So, and so on. And this can be written as a times r to the power of n, because you're starting with a. So for the first term, when n is 0, your first term is going to be, let's double check here. When n is 0, a times r to the power of 0 is going to give you a, which is your first term. When n is 1, a times r to the power of 1, which is going to be a to the a, which is going to give you a times r, which is your second term. When n is 2, a times r squared, which is what we have as the first term, the third term. So it turns out this general term is correct, and this the lower index should give you the very first term when you plug in, which gave, and then the next term, as you count up, when n is 1, it should give you this term, which is going to be a times r to the power of 1, which is a times r. So that's how we double check if the general term of the series is correct. So for example, 3 plus 6 plus 12 plus 24. So how can we write the general term of the sequence? What's going on with this sequence, or since we're adding up the series? So the first term is 3. And then what is the common ratio? 3, 6, 12, 24. What's going on? It's, we basically multiply each term by 2, then our common ratio r is going to be 2, and it's an infinite sequence, so it keeps going. If we want to put, so the first term should be 3, so let's put n equals 0 and n, so that when you plug 0 for n, you will have 2 to the power of 0, which is 1. 3 times 1 is going to give you 3, which means the general term is correct. If you plug 1, which should be the second term, it's going to be 3 times 2 to the first, which is going to be 6. So that's the idea of geometric series. So let me give a break and make sure if there's any questions. Any questions so far? Okay, I'm assuming there is no question. Let's keep going. So let's talk about the partial sums of geometric series. Sn, the nth partial sum, as we defined, will be the sum of first n terms. So if you start from a, it will be a times a plus a times r plus ar squared all the way to a times r to the power of n minus 1. Why n minus 1? Because we're starting from a, so, and you need to have n terms. So if you start from a times a to the power of 0, then you need to stop at n minus 1 so that you would have n terms. And what about r times Sn? If you multiply all these terms by r, ar plus ar squared, ar cubed, all the way to a r to the power of n, because we're multiplying all terms by r. So if you subtract Sn do it this way. If you subtract Sn from Rsn, I think we're gonna obtain something interesting. Rsn is AR squared, all the way to ARN, and Sn is gonna be AR plus AR squared, AR n minus 1. So if you do that on the left-hand side, you'll have R times Sn minus Sn. And if you distribute this minus over all these terms, ARs will be gone, AR squares will be gone, so is AR cubed all the way to R to the power of n minus 1. So what you will have is A times Rn minus A, because this A didn't get canceled. So is this subtraction clear? We're gonna obtain a general term for the nth partial sum. Any questions so far? So let's try to solve this equation for Sn. Obviously, Sn is the common factor here. And A is the common factor on the right-hand side. So Sn is going to be A times R to the power of n minus 1 over R minus 1. Now, if we're talking about convergence and divergence, if R is greater than 1, if you have a number that is greater than 1, let's say 2, as n goes to infinity, it will blow up and it will be infinity. So if R is greater than 1, this term is going to be infinity. So we can't calculate the nth partial sum. But if R is less than 1, if its absolute value is less than 1, as n goes to infinity, remember, the limit is going to go to 0. So this is how we can express that. If R is less than 1, then R to the power of n goes to 0 as n goes to 0. I want to give a small example to understand that. For example, what is 1 over 2 to the power of n as n goes to infinity? If you keep multiplying 1 over 2 by itself, it will keep decreasing, and eventually it will be zero, right? Because it's less than 1. If you multiply a number by itself, if you multiply a number that is greater than that is less than 1 by itself, it will keep decreasing, and eventually it will be 0. Example. So if you have the common ratio R, whose absolute value is less than 1, as n goes to infinity, R to the power of n will approach to 0. So let's take the limit of Sn A times R to the power of n minus 1 over R minus 1. As we said, this is going to go to 0. We'll have A times -1 over R minus 1. In other words, A over 1 minus R. So it turns out the sum of the series, in other words, the limit of the sequence of the partial sums is the first term A over 1 minus common ratio. R. So that's the formula we need to find the sum of the geometric series. And if R is greater than 1, then there is nothing we could do about the sum. So it will be divergent. Let's say, to sum up, this was the proof, but the fact we will be using is the geometric series a times r to the power of n, a plus a r squared, a r cubed, all the way to the infinity, is convergent if the absolute value of r is less than 1 and its sum is a times r to the power of n, which is the first term over 1 minus r. If r, the absolute value of r is greater than 1, greater than or equal to 1, then the geometric series is divergent. So any questions so far? We showed and stated the facts, so we're going to move to examples. Let me know if you have any questions, and if you think I'm going too fast, please let me know. I can slow down. I'm assuming that you're not taking notes as I write, because this is being saved, and also, as I said, I will post the paper I'm writing on right now, so you don't have to take notes during the session. If I'm assuming you mean it's the absolute value of r that is greater than or equal to 1, then the geometric series is divergent. Is that okay? You mean 1 minus r? Yeah, you can put it that way, because if 1 minus r is negative, it means r is greater than 1. Yeah, it makes sense. But I would say the easier way to figure it out is when you're given a series, which we will do some examples, try to determine r. If the absolute value of r is greater than and equal to 1, then the series is divergent and the question is finished at that point. But if the absolute value of r is less than 1, then the geometric series is convergent, and you're expected to find the sum of the geometric series using the formula a over, in other words, the first term over 1 minus common ratio. No problem. Any other questions? Okay, then let's move to examples and let's see how it goes. determine whether the geometric series is convergent or divergent. If it is convergent, find its sum. So the first step is going to be finding the common ratio of the geometric series. So 3, -4, 16 over 3, -16, -64 over 9. So how can we find the common ratio of this series? If you know that the way the geometric series works is you're multiplying the first term by the common ratio and it should give you the second term. Or you're multiplying the second term by the common ratio, it should give you the third term. So to find R, the common ratio, we can set up what number do we need to multiply 3 by to get -4? And how would you express that in math language? 3 times R is equal to -4. Or you can do it for the second and third term. -4 times R is 16 over 3. It will give you exactly the same answer. So 3 times R equals -4. R is -4 over 3. Does everybody agree with that? Or if you want to calculate this one, R, it will be 16 over 3 over -4, which is going to give you -4 over 3. So if R is -4 over 3, its absolute value is 4 over 3. Is it greater than 1 or less than 1? It's greater than 1, so it's divergent. And the question is finished. Any questions on the first example? Okay. The second example. -3 to the power of n minus 1 over 4 to the power of n. So first of all, we need to manipulate this general term to a geometric series form, because the general form of geometric series is a times r to the power of n, or a times r to the power of n minus 1. But this doesn't seem that way, so we will need to do some algebra. What we can do is negative 3 to the power of n minus 1 can be rewritten as negative 3 to the power of n over negative 3 times 4 to the power of n, because the power of n minus 1 means power of n over power of 1, which is going to be on the bottom. So you will have negative 3 to the power of 1 on the bottom. In other words, just negative 3. And this can be rewritten as one over negative 3, which is going to be your a negative 3 over 4 to the power of n. Now, this looks like a geometric series form. And then what is r? The common ratio is negative 3 over 4. Its absolute value is less than 1. So then it's convergent. Now let's find the sum. It's going to be the first term of the series over 1 minus r. What is the first term of the series? So you have a couple of options here. You can plug in the original series, or you can plug in this form or in that form, doesn't matter. So to find the first term, you need to plug 1 for n and calculate the corresponding number. It's going to be negative 3 to the power of 1 minus 1 over 4 to the power of 1 over 1 minus negative 3 over 4. Any questions so far? So this is going to be 1 over 4 minus minus is going to give us plus 1 plus 3 over 4. And it will be 1 over 4. If you find the common denominators, it will be 1 plus 4 over 4 plus 3 over 4, 7 over 4. And the 4's get canceled. The sum is going to be 1 over 7. So any questions so far? Have I got R? Yeah. So R is the common ratio, as we said, which means all terms in geometric series, it's I mean, each term in geometric series is found by multiplying the preceding term by R. So I think you mean the second example. In the second example, we need to manipulate the given series to a geometric form, and the general form of geometric series is a times r to the power of n, or a times r to the power of n minus 1. The power doesn't really matter, but it should be in the form of a number times common ratio to the power of n or n minus 1. Okay, but if you check out this series, you have a minus 1 and n, so it's not in this form. What we can do is we'll either rewrite negative 3 to the power of n minus 1 in terms of n, or we'll rewrite 4 to the power of n in terms of n minus 1, so that we can combine these two exponential numbers. So I prefer rewriting negative 3 to the power of n minus 1 in terms of n. So to do that, you need to move one -3 to the bottom so that you would have -2 to the power of n and one -3 on the bottom. I didn't do anything on 4 to the power of n. So now what you have is a constant number of -3 on the bottom, which is going to give us the constant number in the geometric series. And r, since they have the same exponentials, we can combine them, so we can rewrite them as -3/4 to the power of n. Now, if you check this expression, it's in the form that a constant number times r to the power of n, which is a geometric series form. So once you have that, to check the convergence, you're just checking the absolute value of r. If it's less than 1, it's convergent, as we said. And if it is convergent, then we gotta keep going to find sum. And the sum is found by, I don't want you to memorize the formula involving a. I just want you to think of first term over 1 minus common ratio. So what is first term of this series? You need to plug 1 for n to find the first term, which I did. If you plug 1 for n in that, you will have -3 to the power of 1 minus 1, which means -3 to the power of 0, which is 1, over 4 to the power of 1. And the common ratio, we know that it's -3/4, so I just plugged it for the common ratio, and the rest is basic algebra. Is it more clear now? Any other questions? No problem. Okay, then let's keep going. We have a small theorem to solve the next example. If you have two series, an and bn, and if both of them are convergent, and so are the series constant times one of the series, or the sum or the difference of the two series. And we can write from 1 to infinity c times an. So we can pull the constant out, and it can be rewritten as c times the series an. And the second property the sum or difference can be split into two series. So by means of this theorem, we can do the third example. So we have sum of two terms. So what we can do is we can split them up and handle them separately. If both of them are convergent, then we'll be able to find this sum. But even only one of them is divergent, then the answer is just divergent. So the first one, I think it's already in the geometric series form. You can think of this guy as a times r to the power of n, and a is just 1. So the common ratio is negative 0.2. Its absolute value is 0.2, which is less than 1. And what about this one? This is also in the geometric series form. R is 0.6. Its absolute value is also 0.6. It's less than 1. So this is convergent. This is also convergent. And the theorem we just covered states that if they're both convergent, then their sum can be found. So let's do the sum. The sum of the first one, again, the first term over 1 minus the common ratio. And the second one, again, the first term, if you plug 1 for n, I think you would get 0.6 to the power of 1 minus 1 over, what is the common ratio? R, which is 0.6. So then this is what you would get. So all we have to do is calculating this sum. Any questions so far? Okay, then let's finish this. Minus minus is going to give us plus, so you will have 1.2, and this is going to be 1 over 0.4. I think the easiest way to calculate that is converting them into fractions. So 0.2 and 1.2 is going to give you 1 over 6, and 0.4 is you know 2/5. So you would have negative 1 over 6 plus 5 over 2, which is going to be 7 over 3. So that will be this sum. And obviously it's convergent. So any questions on this example? Again, if one of them was divergent, the answer would be divergent and you wouldn't need to calculate any sum. But since they're both convergent, we can calculate the sum of these two series, and the sum of these two series is going to give us the series, the sum of the original series. It will probably be on Wednesday. You don't get to pick the day. It will probably be on Wednesday. I'm still waiting for Dr. Fang to finalize that. You don't get to pick the day, but I think you'll get to pick the time. Maybe it's still unclear. He hasn't said much, but it will probably be on Wednesday, so you don't get to pick the day. And I'll make. I think it will be longer than that. I'm hoping it will be longer. Yeah. No problem. Any other questions? Any feedbacks? Anything you want me to change on That's a good question. I don't know, but hopefully he'll be more merciful. Let's hope so, but I don't know. Any other questions? I already released the correct answers to practice stats. It's in the exam 2 file, the exam 2 folder. I'm not sure about the partial credit. I think there will be space that you can write your work, and then I'll grade that. But I don't know yet. I'll make an announcement on the exam. So you have about a week. We'll clear it up. Yes, you can expect that. Yeah, especially the question distribution. I think it's going to be very similar. The difficulty, it might be a little easier, hopefully, but that it will be a good practice to do the quiz. And you know what? I'm claiming the quiz as extra credit. If you don't do quiz, you have nothing to lose. But if you do it, I'll just add that. I'll just add the points you get from the quiz onto your homework score, so it will be extra credit. So I highly encourage you to do the quiz on WebAssign. Yeah, tomorrow night, but I can extend it. I think I'll extend it to the weekend. Yeah. Yeah, I'll change to do today. I'll extend it to the weekend. Did I answer all questions? Yeah, the right answer, the answer key is on Canvas. And also I put a lot of explicit solutions on Canvas. So please check the files and the exam 2 folder. It's gonna be, oh, you mean the right answers for the quiz? Okay, okay, my bad. I thought you mean the right answers for the practice problem. Okay, yeah, I'll do that. Yeah, I'll give you the right answers for the quiz on the weekend. No problem. Any other questions? Then yeah, I think it was March 23rd. Yeah, but if you need extension on homeworks, just send me extension request through WebAssign. I'll do that. But if you finish the homeworks before the exam, I think it would help, to be honest. Yeah, no problem. And I will start my office hour session at 11, which is like 2 minutes later. So if you have more questions, you can join the office hour session. I wish everybody a happy hump day. And I'm ending the meeting.